I'm Mike Farrington. Welcome back to the boardroom. I recently installed a massive dust collector that I purchased off Craigslist. I'll cover some of that installation in this video. I'll talk about why I wanted to upgrade, and I'll intersperse some tips and tricks that I've learned from the few dust collection systems that I've installed over the years. I got started by erecting the dust collector and bolting it down to the floor. After that, I drew out a plan of how I wanted my ductwork to be laid out. I refined that plan so I could actually see what I wrote. Then I headed over to a local HVAC supply company and purchased all of the necessary fittings and pipe. I found cutting the 8-inch pipe a little tricky. My chop saw here doesn't have enough capacity to make it in one swipe, so I had to cut and roll, cut and roll. I decided to use pop rivets to connect all the pipe together, and the process goes: drill a pilot hole, put the pop rivet in, and use a special tool to lock everything in place. I'll talk more about rivets a little bit later in the video. In addition to the rivet gun, I also used what's called a crimping tool, and if you have two pipes that are of equal size, if you take and crimp one of them, it makes it slightly smaller so that it can slide into the other one. The guys who worked at the HVAC supply house were not as nice with this pipe as I think they should have been, so I found myself straightening dents and dings from time to time. And if this whole cabinet maker woodworking thing doesn't work out for me, I'll use this portion of this video as an application to a local body shop, and I can pound out door dings. Buy or build dust collection shrouds. No dust collector, no matter how powerful it is, can collect the dust coming off the top of a saw blade. That blade is spinning at almost 100 miles an hour unless it's enclosed. By putting an enclosure over the blade, adding some dust collection to that enclosure, it ensures that the dust is collected before it's launched into the air. The two most common ways to join a spiral pipe together would be with self-tapping sheet metal screws or with pop rivets. I went with pop rivets because I found that drilling the 1/8 inch pilot hole took a lot less force than it did to drill the self-tapping screw through the sheet metal. This is important because I was working above my head and my right shoulder isn't in the best of condition. So in other words, the pop rivets felt less physically demanding. And I picked up this cheapy rivet gun for about 12 bucks, and boxes of 100 rivets are 5 bucks. So using this method to connect spiral pipe together is reasonably cost effective. I also found rivets to be fairly easy to reverse. Simply drill the top of the rivet with the pilot bit for a second or two. That breaks the connection. Second set of hands would have been useful for this project. However, I'm human and only have 2 hands. So I found that a ladder with the proper clamps and shims and so forth made a perfect work support for the other end of the pipe. Getting accurate real-world measurements was a challenge. This is the old school way. I come up with another better way that I call the new school way, and I'll show that later in the video. Whenever possible, I would make assemblies on the ground because this is way more convenient than trying to do this all overhead. And this wacky looking fixture is what diverts suck to my bandsaw, table saw, and sliding table saw. There are 2 types of fittings in the ducting world, airtight and not airtight. The fittings I went with were not airtight. This meant that I had to come back and add a sealer. And the look on my face is of concentration, not the need to go to the bathroom. For this installation, I went with a spiral steel pipe versus PVC that I used in the previous couple of installations. I did that mostly for cost. I wanted to go to an 8-inch diameter main line, and 8-inch diameter PVC pipe and fittings are very expensive versus still reasonably cost effective with the spiral pipe. I think if you're going to buy either one, you should go to a professional supplier. Go to a gardening center for the PVC. Go to an HVAC contractor supply for the spiral stuff. Both of them make really good dust collection pipes. I think that actually up to 6 inches, PVC is a better choice. The inside of the pipe is smoother, the way that the fittings come together really create a nice smooth flow so that air isn't disrupted or slowed down. As with the spiral pipe with crimping and things like that, there's just more internal imperfections in the pipe. Both of them are reasonably easy to work with. I would say that PVC is easier. It could be cut with a chop saw versus this has to be cut with some sort of metal grinding saw, either an angle grinder or a metal chop saw. One downside though to the PVC is static. Static electricity causes dust to stick to the outside of the pipes. That's really annoying, especially if you roll up your garage door and a little breeze comes in and then there's just dust floating everywhere. That can be mitigated partially by running screws into the pipe and then connecting a ground wire to all those screws and then onto the dust collector. With the spiral pipe, you don't have to worry about that.
Daddy, I need some more holes.
This stuff is called hanging strap, and I used it to hang the pipe from the trusses. I used a nut and bolt to form an appropriately sized loop, and I would put a dot of Loctite on that just to make sure it doesn't come undone in the future, and a couple of screws will secure it to the truss. Though absolutely necessary in some applications, flex hose is not very good dust collection hose. The ribbing that allows it to flex creates too much internal resistance. So anywhere possible, run solid piping as close to the machine as possible, then use the fewest feet of flex hose. Okay, so here's the new school method of pipe measurement. I would use a vertical laser line, put it right on the pipe, then I would mark that on the ground. I would do the same to where I want the pipe to go to, mark on the ground, and then I would measure off of those 2 marks. And just in case you didn't know this, Goonies never say die.
I'm just eating.
Vent a dust collection system outside if possible. This system, the exhaust runs through this filter, which is normal. In my opinion, it would be better if I had a manifold where I could select between venting outside and venting through the filter. These cyclone separators do a good enough job to that the air coming through the exhaust is actually clean enough to where if you pump it outside, you're not going to coat everything in dust. The one consideration to this is heating and cooling. Here in this shop, about 6 months out of the year, I would want to vent through the filter to keep the warm air in. The other 6 months out of the year, if I was pumping air outside and I was drawing in some fresh breeze, that would be a good thing. That's a project that I hope to tackle at some point in the future where I could make a manifold that would allow me to select between the 2 options. Some of this final detail work is the most challenging. I put a lot of thought into positioning blast gates and these elbows in such a way that they were convenient to each of the tools that they were directed towards. I think one important thing to consider when making a dust collection system is it needs to be adjustable. This offshoot here is for the CNC, which I'm standing on currently, and I realize I'm going to have to go back and redo this later. This is just to get me working for now. Longer term, I'd like to up this flex hose to 6-inch, which splits into 2 4s right at the cutter head of the CNC. Position the dust collector as close to the main dust producing tools as possible. In my previous installation, I had my dust collector located in a closet way over there, and that meant many feet of pipe and many turns to get the ductwork to the tools. This installation I've put as close as possible to my main dust creating tools. This means fewer turns, fewer feet of pipe, and better CFM to each of the tools. One downside of locating the dust collector closer to where I'm working is there's more noise, so I invested in some better quality noise isolating earbuds. Make sure that transitions make sense. In this situation, this is for my bandsaw, I have 6-inch being split down into two 4-inch hoses, and I have this transition that blends those down nicely. Previously, I had a 4-inch hose going into a 4-inch transition, and ultimately what ended up happening was I wasn't getting enough air to either of the two 4-inch ports. With this, the 6-inch splitting down into 4-inch, the math kind of adds up, and I get a good even suction between the two 4-inch ports. I built these vertical boxes out of 2x4s and 3/4-inch plywood. I had two reasons. I wanted a place to be able to bolt the dust collection to so it would be nice and secure when I was operating the blast gates. And I wanted a channel that I could run wires down so that I could mount some plugs and plug my tools in easily and safely. There was a third and unforeseen benefit though, and that is it gave me a great surface to put some screws in, and I can hang things up from those screws. I needed some additional 6-inch flex hose, so I ordered the heavy-duty polyurethane stuff, and it's like so strong it was hard to work with. So I used a heat gun to loosen it up a little bit, and I found that Simple Green's a great lubricant to help slide it on to whatever it needs to be slid onto. Both my jointer and table saw were made a long time ago, back when dust collection meant a broom and a dustpan. So in both cases I had to improvise. I was able to make a plywood shield and then drill a 6-inch hole in that, and that gave me something to attach the ductwork to. A couple of key reasons why I upgraded to this particular dust collector. My previous dust collector was also a 5-horsepower Cyclone, very similar to this one. However, this one has a 16.5-inch impeller versus a 15-inch impeller, which means it's going to move more air. Also, it has an 8-inch diameter inlet versus 6-inch diameter inlet to accommodate that larger volume of air. It has a 55-gallon collection drum versus 30-gallon collection drum, so it's a longer period of time between emptyings. This one has a bin sensor, and what that means is as this fills up, at some point this red light starts blinking very annoyingly, reminding me that I need to empty the collector before it gets packed full of chips and dust. Last and certainly most importantly why I went with this particular dust collector was I got an unbelievable deal on this bad boy off of Craigslist. I added a Y here and capped it off because I plan to expand the system over to the adjacent wall where I'm going to have a sanding station. And this is kind of the opposite of what I said earlier, to move the dust collector closer to the tools. In this case, I moved the tools closer to the dust collection. But I actually like having the tools here. I think it was a good move, and it'll make sense to have a sanding station located here in my shop. So I guess this project is done enough for now. It's not totally complete. There's still some loose ends and some adjustments that need to be made, but I do have a functioning dust collection system. One of the things that I worked hardest on was to put all the blast gates in locations that were easy to get to from whatever tool I was going to be working on. And I think I did a pretty good job of that. And now I have no excuses to not turn the dust collector on even just for a quick cut. It will probably go unnoticed, but I plan on using this system in many, many future videos. So until next time, thanks for watching.